Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Faiz Ghazali, metric number 1814113. So today, me and my group mate, Amin, will present about our remote sensing and telemetry project, which is the telemetry for AIS using SV651 for 43 MHz and also RockBlock MK2 using the Iridium satellite. So a little bit introduction about our project. First of all, AIS is a system used by ships and vessels for identification at sea. AIS helps to resolve the difficulty of identifying ships when they are not in sight, for example, at night or in radar blind arcs or shadows or at distance, by providing ID, position, cost, speed, and other ship data with all other nearby ships and VTS stations. So the ship data is displayed on an AIS data capable chart plotter with and ship symbol or even an AIS data capable navigation software. The AIS transponder automatically transmit the position and velocity of the ship at regular intervals via a VHF radio built into the AIS. So the position and velocity originate from the ship's GPS, or if that fails, from an integral GPS receiver. The AIS also receive heading information from the ship's compass and transmit this at the same time. So there are also some drawbacks for this AIS system. One of them is the piracy problem. So as we know, pirates are new, just their tactics and equipments are. They have better boats, better guns, and much more sophisticated electronic guidance system, including AIS. So they also have AIS. In spite of all the ISPS security measures, they use USCG mandates that the ships broadcast all the information about the ships to the whole world in real time. So AIS broadcast the position accurate to GPS standards, the cost, the speed, destination, and number of crew aboard, as well as the ship's flag. So it's like a menu for the pirates and terrorists to plan attacks on the ship when and where they are most vulnerable. So there are some of the drawbacks for AIS. So this is basically the project concept for AIS. The objectives of our project. The first one is to transmit the position of a ship using GPS to base at regular intervals using RockBlock Iridium and also SV651 for a distance. The SV651 is used for a distance below 3 km and the RockBlock Iridium is used for a distance above 3 km. So the second objective is to receive the transmitted GPS data by using Iridium cloud monitoring and also local ground control station. So the first component that we use is the Garmin GPS 19X HVS. It consists of an antenna and also an integrated receiver. It can track many satellites simultaneously. And this GPS is built to survive harsh operating circumstances. So it's suitable for our operation. And it is also waterproof to IEC 60529 IPX7, which I can go below 1 meter for 30 minutes. It's waterproof for 30 minutes. And it also uses the GLONASS-based tracking. So GLONASS is an acronym which is translated from Russian. This means Global Navigation Satellite System. It is accessible for both military and civil use and also provides real-time position and velocity determination. The main difference between GPS and GLONASS is that with GPS satellite use the same radio frequencies but have different codes for communication, while GLONASS satellite have the same code but use different frequencies, allowing satellite on the same orbital plane to communicate. So the next part we use is the RockBlock MK2 Iridium. It can be used to send and receive brief messages from anywhere on the planet. The Iridium that we use is Iridium 9602. It uses the 9602 satellite modem, which is the heart of the RockBlock. The only satellite network that permits data to be transmitted from any location on Earth is the Iridium satellite. The message transmitted by Iridium arrives either via email or directly to the user's web services. So the last part we use is the SV651 for 433 MHz. It is an industrial grade and highly integrated RF transceiver module. It has high sensitivity and output power of 500 milliwatt. It is allowed for a long RF range and dependable RF transmission. It has 40 frequency channels and customizable net ID to prevent interference. So these are the three components that we use for our project. The project overview, how we use the RockBlock. The RockBlock, the first step is the RockBlock 9602. It communicates with the Iridium satellite to send and also to receive data. And the second, the Iridium satellites communicate with the ground-based station to send and receive data between space and Earth. The third step is data is sent between the Iridium ground stations and the Rock7 server. The server can be accessed via a web interface, like I mentioned before. And the last step is the specific application talks to the Rock7 servers. So during we make our project, there are few problems regarding the design of our project. The first one is we encounter a problem to receive a serial data from the GPS. Yeah, we have difficulty to solve problems of different logic levels Arduino TTL to RS232 to read the GPS data. So as you can see here, the GPS, it used CMOS logic level from 0 volt to 3.3, while conventional RS232 signals are either in the range of positive 3 volt to negative 3 volt, as shown here. So the second problem is that the RockBlock integrated antenna that we use needs a clear view of the sky. We try to use the antenna at a building, inside a building, but we cannot get a good coverage. But when you use the antenna at open space with a clear view of the sky, then we have a good coverage of the satellite. So it is the drawbacks of the component, which is the RockBlock, because it needs to have an unobstructed view of the RockBlock to return a good bar signal, which is 5, to get the data signal. Okay, so the client for our project is Hydrokinetic Technologies. They want to install the AIS to their boot. So for the next part, which is the project demonstration, I will pass the mic to my colleague, which is Brother Amin.
Assalamualaikum warahmatullahi wabarakatuh. My name is Amirul Amin, 181-395. So I will continue from where Fidaus left. So the next part in this project is the demonstration of the working model of our AIS data system. So the first part is the demonstration of the GPS location acquisition. So this is example of the video that we created to get the GPS signal to transfer it to the Arduino in the form of serial communication. So as you can see, in this setting, Garmin GPS is capable of outputting either 10 Hz or for every 100 millisecond of 1 GPS data, or at 1 Hz pulse for every second 1 GPS data. So this setting is interchangeable in the GPS setting by putting different resistor value at the GPS TX to the ground level. So the next slide. So this is the example of real-time video monitoring that we get from the serial reading of our Arduino that is transferred from the GPS. So as you can see, there are multiple formats of GPS, including GPRSM, but the one that we mainly use is GGA. So the GPS will output a string of data, which later will be translated into multiple value of data, such as longitude, latitude, speed, bearing, and elevation of the GPS. Next slide. So this is the location data that we get. So by calibrate, after getting the GPS raw data, we need to calibrate it. A conventional GPS calibrate the GPS position by using triangulation of the cell tower and local atomic clock time that they get from the satellite signal of the GPS. But since we don't have the RTC clock, we need to manually calibrate the GPS input. So as you can see, from the input that we get and the local GPS from Google Map, the parity difference between these two locations is around 57 kilometers. So we need to plus or minus the raw GPS data in the latitude and longitude string to get or to calibrate the precise position. Then only then we can get a valid value of reading from the GPS. Now, after we get the GPS data from the Garmin GPS, we need to process the data after calibrating it. So the valid AIS data from GPS is acquired through the data from the GPS. So the GPS will output data like latitude, longitude, GPS quality, direction of heading, number of satellite, accuracy in horizontal plane, altitude from sea level, height of antenna, which is set by user in the string, and geodial separation. So geodial separation is the altitude difference between the Earth model and the real altitude difference. For example, the Earth model is perfectly round, but if we have a high elevation like in the mountain or some kind of hill, so this is the value that we get from the geodial separation. And now for the useful data that is required by the AIS format, so the only type of data that we send from the GPS to the AIS is the latitude, longitude, speed, accuracy of the GPS, and the heading. Heading means bearing or direction of where the GPS is currently going. So the other AIS data that we need to include other than GPS is manually included. Some of the other data that AIS format required, including date, time, message type. So message type in AIS format, basically there's two types. The first one is position message. Position message is transmitted when the vessel or the ship is moving. And the type 2 is static message, when the vessel is not moving or at anchor position in the middle of the sea. And some of the other important AIS data that we need to manually include in the AIS data format is country of origin. Sometimes this country of origin is visually represented by the flag that the ship carry. The other one is data connection, whether it's terrestrial or satellite. This means that where the AIS data is acquired, it can be transmitted through terrestrial, which is land-to-land transmission using the 433 megahertz, for example, or through the satellite that comply with the AIS data transmission. And next is the MMSI. This is the same like identification number, but for ship. So they have a unique number for each ship that is sailing on the sea and is in comply with AIS data standard. And lastly, the length and width of the vessel. There are more to AIS data type that need to be transmitted, but here is some of the most important that most of the ship transmit. Okay, next one is data processing. So AIS data, as Firdaus explained earlier, is prone to pirate activity, and it will introduce new risks to the small vessel or vessel that carry high value items or equipment. So AIS data use two-layer encoding. The first one is the string data is encoded to binary, and next the binary data, the 10, is encoded to a hexadecimal encoding. So the format of maritime navigation and equipment for the AIS is defined under the ISO standard. And for us to encode or to decode the AIS data, we require special software or library to read the real value that we get from the AIS reading. So this is the example of AIS data, as you can see here. On the top image on the right is first is the date and the time that the ground station received. And the next line is AIVDM is indicator that this is AIS compliance data. And as you can see, this is like a gibberish string. We cannot translate it properly unless we have the decoding software to translate it back to the real value. So this is the example of AIS decoding message format. So the first bit represent the message type and so on. This is the example of real AIS data that has been decoded in the South China Sea from year 2020 to the recent 2022 in the month of June. In this AIS data, we have the date and the MMSI, which is the identification number of the ship, the message type. In this case, it's a moving message type, meaning the ship is inbound to some place. The latitude and longitude of the ship with the speed and not the course and the heading of the ship. And next is the flag, which is identify the original country of the ship. And lastly, we have the collection type. We can see this is some of them is terrestrial and some of them is gathered from satellite. And for the last part is data transmission. So by transmitting those collected data from Arduino, we transmit it via RockBlock to the cloud station. So this is the example of web interface provided by RockBlock Iridium. So the maximum data transfer rate when powered by Arduino is 5 minutes. It needs a charge time to charge the supercapacitor on board. And to save to clock. As you can see in the RockBlock Iridium web interface, we have the collected data, which is transmitted in the form of string. So for the first part, we have the GPS data transmitted, and the lower second part, we have the example of AIS data. And the Iridium RockBlock has price plan. So for every 50 byte, we need to pay 1 credit. And 1 credit equal to 70 cents in Malaysian ringgit. And lastly, after transmitting the GPS data to RockBlock Iridium, we also transmit it to the terrestrial communication using the transceiver, SV651 transceiver. And this is some example of the data that we get. That's all from us. Thank you for participating with our webinar.
Telemetry for AIS. Sekali lagi, babi lah. Today, me and my friend